All righty, what I wanted to do, today we were supposed to do review, but what I wanted to say is we need to work a little bit on 5.5 because we didn't really talk about it on Monday enough. The other thing I'm going to do is I'm going to extend the deadline for Friday night. So if you didn't finish it, you could finish it later. When we look at the schedule, you'll see the exam or the test is on Monday for chapters 5 and 10. I'll get over there in a minute. Here's what I have to say about word problems using proportions. There are literally 8 different ways to set them up. 8. Now, 4 of them are wrong. So if you happen, if you haven't tried every single way, then you could easily still be wrong. So what I want to do is just pick one little problem that describes what we need to do. And keep in mind that there are so many ways that there's, just because I did it one way doesn't mean it's the only way. So here's an example of these type problems. A woman drives her car 270 miles in 6 hours. Okay. If she continues at the same rate, how far will she go in 10 hours? So that's basically what the problem is about. Now, I took notes from this first sentence. She would drive 270 miles in 6 hours. How far in 10 hours? Now, I did that because I like to get away from the words and into the numbers. Here's what we have. This is one distinct way that's correct to solve the problem. So in other words, 270 miles equals 6 hours. And then how many miles for 10 hours? Now, as I explained earlier, there are 8 ways to do it, 4 ways that are correct. This is just one of the correct ways, but it seems like the path of least resistance because all I did was take notes and then turn it into a proportion. Now, the interesting part about it is when you do it this way, not only do numbers cancel and everything else, but words cancel. So the word hour and hour cancels like numbers would cancel when you had the same number on top and bottom. And so what I want to do is finish this problem. And if you recall, what you need to do is cross multiply. And so you can do it in either order, this times this or this times that first. If you like to have the X on the left, which some people do, then you might do this one first. This is X times 6, which we would write correctly as 6X equals 270 multiplied by 10. So I did this one first. It doesn't matter because the equation could be either this way or the reverse way. And so what I need to do first is simplify this. 270 times 10 is 270 with an extra 0. When you multiply by 10, that's a decimal shift. This is equal to 6X. And what we learned in the previous section is that when you want to solve for 6 times X, and that you could put a dot there if you want to, I don't care. You need to divide by 6 so that the X becomes by itself. And to be fair, you have to divide this side by 6. So 6 over 6 is 1. 1x is x. And the answer appears when you divide this out. So you can do it longhand, 6 into 2700. That would be 4. 6 times 4 is 24, 3 left over. 6 into 30 is 5. And that comes out even. And I've run out of paper, but it's 450. Okay, so then you go back and say, what did you figure out? X, which was this number here, was 450, and it was miles.
Good morning.
So that was the missing answer. Go ahead. Whoever's talked, go ahead. I lost him. So
No, she just said good morning.
okay, so one way to check it is 270 times 10 equals 450 times 6. They will multiply out to be identical numbers. And so there's our answer. X is 450. Now, do we need to look at all the different ways to set this up? And the real question is maybe. But the other way to set it up, which is reasonably, makes fairly good sense, is the 270 miles corresponded with 6 hours. So that was the first sentence, and I could put them vertically like that. Whether that makes more sense to you, I don't know. But then when you fill in this side, you've got to match horizontally and vertically. So this would have to be the miles, and this would have to be the hours. Now the miles we did not have, so that, X or some N or some number like letter like that, but hours had to be 10. When you look at this setup, it's 270 times 10. 270 multiplied by 10 equals 6 times X. And if you look at that problem, that's the identical problem we just got through with. 270 with one more 0 equals 6X. It doesn't matter that the 6X is over here on the right. The goal is to get X alone. And so since 6 is multiplied to X, you've got to divide by 6 both sides so that you get X alone. So this also is a correct setup. So the first time I set it up was I put 270 and 6, and then I made the match underneath. This time I put the first sentence vertically, but matched them over here. Now the confusion could be that when you set it up, you've got to have match like this. You've got to match vertically. This number went with that number. This number was miles to miles. That had to be set up. So before you get started, you'll get part credit for going this far, because in a way, this is half of the problem. But the second half, when you get ready to solve it, is the cross multiply. And so it's this number times this corner equals this number times that corner. I think the only other versions of that is to start over here on this side. Who cares? Right? As long as you have this vertical and horizontal matching in your initial problem, you will have a correct setup. So can somebody give me a particular, in fact, I think I
saw a problem. I had to look at it, but it was the train one. I think in 5 point. Oh crap! I'm sorry. I forgot the exact number, but it was like 1/87th the size of the trains, and then they had a list of I don't know if we're gonna be tested on something like that, but it threw me off. I just said, you know what? I'm gonna have to cut the things off with this one.
Okay.
But
Well, that's good. I like throwing problems out if you can't deal with them.
well, you shouldn't.
Was
No, I'm
this
just
the
kidding.
homework?
It was a homework. I'll look for it and I'll tell you in a
It
couple
was the
seconds.
scales, wasn't it?
It was scale.
Yes. Oh my
This,
gosh.
we
Sophia,
can
you
do
feel
it.
my pain. I couldn't.
We
Me
can do it.
neither.
What I want to do is see if I can't deal with this.
I'll find it and then at the end I'll bring it up for you if that's okay. So we can just move on.
This problem, okay, this is the one I'm going to go over. This one, it was 34 cents for 1 mile. And I said per mile. So it was 34 cents represented 1 mile. So I'm setting this up horizontally. 34 cents was 1 mile. So then I have 430 miles. I've got to put it under miles. Miles to miles. This will be in cents, but this is the missing number because it said, what's the cost? Which is dollars or, money. What's the cost of this? Now, what we can do is we can solve this now, but the problem is it's in cents. And the problem called for writing it in dollars. So one approach, this is not the only approach. This is a fine approach. This will get us there. But one approach would be to turn this into dollars straight away. 34 cents is actually this in dollars. Isn't that correct? So
Yep.
the 34 cents becomes 0.34. This is X. This is 1 mile, remember, and this is 430 miles. This is the reason I kind of like this one slightly better because I can kill the miles and the only unit I have left is dollars. So this is correctly set up. And so now I'm going to solve it. And so it's this one times this one, 0.34 multiplied by 430 equals X times 1, which we write as 1X. Now you could write 1X, or if you've gotten past that, you would just say X. So what's left here is to multiply these two. This will now work, and I'm like everybody else on the tired, you don't mind. 146.20. I cheated. But this is in dollars. Is that correct? Did I make a mistake? I don't think so. I used a calculator. How is that? So in some ways, when you compare these two starts, I think this was better because it was an easy job to transfer this to this. Then it was in dollars. Then the final answer was in dollars. And if you want to be exact, this is 34 cents multiplied by 430. The miles are gone. And so when this is in dollars, the result of this times this is in dollars. And so there you are. Did somebody find another one? We have a pattern here that will work for every last one of these silly problems. And I'm going to continue to do them similarly. So, you know what I'm saying?
I think
So
that's
try to be too creative.
That's the coolest part because I'm one of those people who stares at a problem and maybe watch a video for 30 minutes trying to figure it out and probably opening a book. So when I was like, oh, that's how you do it. 33 hours later, I make it harder on myself.
Well, all I can say is you've become a better person in the process.
Good say. I'm a vet, so we had to wait for a while, you know what I mean?
Well, waiting, and also, honestly, all these problems will break down if you don't give up. I'm in favor of don't giving up. So did you find Mary, did you find that problem you were looking for or not?
We can't see the homework.
Oh, I'll go there in a minute, but I thought maybe we had some that we could just,
Well,
yeah.
yeah.
Can you see the paper? I hope. Well, I haven't written anything, but there it is. I'll write as soon as you have something. Does anybody have another one for sure? Or do you want me to go to the homework? Go to the homework?
Yeah, I didn't write anything to review, and I try to go back on the homework, and Sophia.
Okay, let's just get out of
There's-
here.
There's one of the train in the book. I can't access the homework, but there's a similar, it's like the same problem, but it's in the book. It's about model trains. And so there's a chart of scale and ratio
Yeah, I'm going
for
there.
the model train. Okay.
Hey,
Hopefully,
I was so
I'll
confused.
get there. Let's get over there and see if we can't find the silly train.
Yeah, Jamie, that's the one we were talking about too. The death
Yeah,
problem.
I used multiplication for it and then divided by 12. Yeah, which in the homework they don't instruct you to do, but in the book they do. In the book they say, divide to get feet instead of inches.
Okay, well,
Um,
there's an extra problem there. So
yeah,
let me go to this. I think this is what we want. So does anybody have a clue about where to look approximately?
I am gonna, let's see. Da, 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 da.
Chickens.
Yeah, that's
Here we
one.
are. You ready?
Did you, oh, that's it. Yeah.
Okay, we take a deep breath. So the size of the train relative to an actual train is referred to as a scale. Each scale is associated with a ratio. So for instance, the HO model, I'm going to write that down, is 1 to 87, okay? Or 1 over 87, which is good. And so they just show that they're different trains, and so that's fine. How long is the actual box car, which is HO scale, if the model is 5 inches for the model? Okay, that's part A. I'm going to go back to paper in a minute. How long is an actual flat car? Oh, now we're into different one, LGB. Okay, LGB, the ratio is 1 to 22.5. Everybody finding that on the table? Okay.
Yes.
How long is the actual thing if the model is 24 inches? Okay. Now, they kind of wanted their answer in feet on the part A and feet on part B. All right, I'm getting out of that. I'm going back to whatever I do. Okay, those are my notes. So I'm going to do the part A first. And part A, this was about HO trains. The scale was 1 to 87. Now I could write it this way, because I can write it either horizontal or this way might make more sense in this problem. So we have to label this. The 1, oh, I know the problem. This was this 1 inch or no? This was just the ratio. So this was the model. And let's call this the actual train. Is that right? Is the model just 1 and the train 87? Can you live with that? The train would be 87 times as big. Okay? That's one side of the equation. And so the reason I put the words in is because I've got to make a match over here. Now, what they said was the model was 5 inches. Oh, I know. Here we go. This is, yeah. The model was 5 inches. And they wanted to know the train. Well, this is the missing value. Now, we have the same exact problem we had before. This is in inches. And when I solve this, this will be in inches. Right? And so either I change it to feet right now, and it's not going to be a nice number. Let me see what a decimal number would look like. 5 divided by 12, clear. Ugly. All right. I'm going to proceed to do this problem in this way. So this is correctly set up. This is the model. Obviously, a real train would not be 5 inches. Everybody satisfied with that? And this would be the real train, but it's going to be in inches. That's going to be. So this is 1 times x is 1x. And this is 87 times 5. 35, carry a 3. This is 40. And 3 is 43. Something's not right. This is not very big train, is it? Or maybe it just was one piece of the train. I forgot.
No, so it's a model train. So what the this once you get to here, you divide 12 into.
You've got to get it into feet. Yeah.
Yeah, to get it into
And
so you divide 435 by 12, and then you get the amount of feet.
Yes. Now,
Yeah,
the real question
that's how I did it.
We haven't done this. Is it clear that you have to divide?
They don't say it. I had to go back into the book and because a lot of times the problem set in the book is identical to what's in XYZ. So I've made it a habit to sometimes do some of those problems before doing XYZ just to have practice. And so I found the problem in the book and it gives you the extra instruction because I got to 435 inches and that's what I put in and it's wrong.
No.
And so I did the extra step of dividing and then I got it right.
Got it right.
So,
okay, so here we go. This will come up before the course is over, but it's clearly 1 foot equals 12 inches. And if you don't know that, you probably should, or you write it down somewhere so that you never forget it, somewhere important. But that's this is the conversion that we need. Now, it's the problem for students is that do you multiply by 12 or do you divide? There is a technique, and it will come up in a bit, but the technique is very good. And I don't think we've done this, but we should have. What you do is you put in the 12 inches and the 1 foot here. Now, we want to get rid of inches. We want to turn it into feet. And the technique is because this is inches, you put inches here and you put feet here. And then you put the proper numbers in. It's 1 foot makes 12 inches. Now, this is actually, this and this are the same. So when you multiply by something that's the same divided by the same, you have not harmed it in a way. And so what happens is the 2 inches cancel each other out. And the only thing you're left with is feet. Now, why did I do this? Because this is telling me what has to happen. The 435 divided by 12, and that will be in feet. So this, when I realized I put 435 over 1, which we're used to doing, when inches was here on the top, I had to put inches on the bottom so they cancel each other and be gone. And then I had to put feet on the top. I'm relying on this. This technique is used in science as well to change from one type of unit to another. And so clearly the answer was to divide by 12. Do you have the answer, anybody? I don't want to do it. 3. I don't know.
36.25.
Okay. Thank you. Okay.
I'm so hurt. This was easy after you guys figured it out.
Okay. Let's do the second one to make sure we're good. So
Mario,
the second,
I sat for like a half an hour to 45 minutes on that problem.
oh, I'm sure. And you know what?
And
I was in the
found the
fetal
book,
position.
so-
No, I'm just
You
kidding.
could
It
send
was
me
so
an
bad.
email, and somebody did. And I explained it to him. I typed it out and I didn't hear back, but I think it probably worked. Part B was the LGB train, and the ratio was 1 to 22.5. So I just write that straight off the bat. Now, this was the model. Okay, and this was the train. At least that's how I'm describing them. Then they said the model was 24 inches. And they wanted you to figure this out. I hope I got this right. How long is the actual flat car? Okay. So this is a horse of a different color, if I can use that expression. 24 inches would go nicely into feet, wouldn't it? So I say, why not? So I go 1 to 22.5. Instead of 24 inches, I'm going to say 2 feet. And this, of course, is X. That means when I'm done, I've got it in feet already. Now, before changing 5 inches into feet, if I divided 5 by 12 and it was a repeating decimal, I said, forget it. But this one here, if you recognize it, that would save you a lot of work. So 1 times X is X. 22.5 doubled is 45. Done. What
You
did
make it so easy.
I know it. I've been practicing. What do you say? Can I work on a different problem from the homework? Were there others that I could actually go after? That's the train problem. But you see, I think this is very straightforward to set this up and say, okay, fine, just get it like that. But then clearly see this was the model and this was the train, at least how they described it.
There was one that threw me off too. I gotta find it. I'll find it in the work, but it was like cents per diaper, right? And then like it's like you had to double it. So say if it was like 33 cents for, I'm sorry, if it was $12.99 for 50 diapers. Now I know the concept now, but it threw me off because it was like
You're supposed
the
to
book
compare
had
the
you.
prices.
Say it again.
We were supposed to compare the prices, right?
Yeah, I like your shirt. That's awesome. Upper left. But no, yeah. I was like
so-
reading it. I was like, oh crap, it's cool. But yeah, to compare the prices.
Any
And
idea about where it was? Anybody else? Diapers, you said? Gas,
something like
pens.
it might have been.
Right.
Was it number 9?
I think
Okay.
no. But
All right, you think
I
it's
think
probably down the
the
road.
last
Okay,
one.
I'm gonna go through pints.
Yeah, I don't think it was 5.5. I
Okay.
think that it was it was more on the ratio or scale no, it had to do with ratio, but it was,
Okay.
it was
See, this is why
further back.
we gotta write
Yep,
these
so
down because I can go
unit
straight. Yeah. Do you want to do another one? A different one? Anybody care
Yeah.
which one? How about chickens?
Yeah.
A farmer knows that every 50 eggs, he has only 45 can be sold, marketable. Okay, so some of them might be broken or something. If the chickens lay 800 eggs, how many are marketable? You've got this figured? Chickens. Okay. So here's my notes. So this was the first sentence. So I'm going to go 50 total eggs equals 45 that you can market. I'm just going to write that down. Now, they're interested in how many can be marketable, which means this has to be X, which means this is already set up in its proper way. This would be 800 eggs. And in this format, eggs and eggs go, and what you're left with is how many can be marketed. Now, I'm going to do this problem one way and then another. 50 times X is 50X. And 800 times 45, I can almost do that in my head. Just 0, okay, 432, 36, 3600 with 2 more zeros. Did I get that right? 800 times 45. 36,000. Okay. All right. So I multiplied 50 times X to get 50X. I multiplied 800 times 45 and I got 360 and I added those 2 extra zeros and there it is. To finish this problem, we must divide by 50. And so 50 over 50 is 1. 1X is left. I'm going to kill these, a pair of zeros. It's dividing by 10. 5 into 36 is 7, 1 left over. 5 into 10 is 2. And then there's my answer. 720 would be marketable. Okay, so I come up here, 720 marketable. Does this make sense? When I had 50 eggs, I could save 45 of them to sell. When I had 800 eggs, I could save 720 to sell. Does that make sense? I think it does. You're going to lose some regardless. But I want to go back to the original setup. 50 eggs, 800, 45X. So these were eggs. This was eggs and that was eggs. This was marketable and that was marketable. although you can't cancel anywhere you like, this 50 over 800 can be reduced. And I probably shouldn't show you that, but it can be done. So there's nothing holding you back from reducing this original fraction. In other words, I could have done that. And then I would have had a smaller problem. 50 over 80 is 45 over x, because this fraction with or without those zeros will result in the same answer. And so I might be tempted. The truth of the matter is 5 and 80 could also be reduced and still not ruin the problem. But I think taking out a pair of zeros made a lot of sense, you know, so that you didn't trip over your zeros. You know, when you do your calculations and you have too many numbers too big, this would have worked. You can't cancel diagonally, but this is a single fraction. And there's no reason not to make it smaller and have smaller numbers to multiply. How do you like that? I always wonder, because then people start canceling all over the place and it's all ruined. But if you keep in mind that it's within the same fraction you're allowed, you should be okay. And I always question whether I should have said that. Because I'll see somebody go cancel happy on me. Did anybody find the missing problems?
Found the missing problem. I found it. It was 5.2.
It was 5.2? Oh
Yeah.
my. Okay, let's find it.
So it was 5.2 question 10, and it was saying find the unit price in cents per diaper for each brands shown below to the nearest tenth of a cent.
Okay.
Thank you.
Yeah, I'm gonna do that one. Let's see if I can find it. Two.
Because I sure was looking and I gave up.
You gave up. Okay, well, that's all right. That's why we work together. So unit price is basically, the word unit means one. So it's really trying to figure out what's the price per one. So here we have diapers, $10 and I'm gonna write this down, $10.99, but it's not one, it's 36. So we're gonna have to divide by 36. And that will tell us how much for one diaper. Do you see that? Think of a simpler problem. If it was $10 and you got 10 diapers, that would be $1 a piece. So you divide. The second part was $12.99 and you got 45. So you got more for the higher price, but the question is, which one's a better buy? And so you still have to fill in the cents. We need this in cents. All right. I'm going back to paper because I think we need to see it.
If I'm not, oh, okay. So I did it different. I think it told us to double it and then divide the sum of both doubling. Like that's what I did, and I got like, and like X. I'll do it after you. I'm sorry, guys. I'll do it and then I'll show you what I got.
Yeah, I don't. I mean, $10, $10.99 got you 36 diapers. So if you divide by 36, you'd see how much it costs per diaper. Because of the time, I'm just going to hit my calculator if you don't mind, so I can get this done. $10.99 divided by 36. And I'm getting this answer 0.3052 and a bunch of sevens. Okay. I'm going to do the same, 12.99 divided by 45. 0.288 and a whole bunch of sixes.
Where are we rounding to? Because that seems to be where I
Well,
go.
I'm getting there. So the real question is, which one's the better buy? And the answer is, this is 28 cents, almost 29 cents for a diaper. This is 30. So this, whatever it was called, B or whatever, that's the one, that's the answer to that. But you still have to put in, there was a box where you had to say how many cents, right?
Mhm.
Now, this is in dollars, remember, because this original, these were all in dollars. And so this is 30 cents though, isn't it? Well, but there's a 5 after it. So the real question is, did they want it rounded to the nearest cent? And I gotta
Yeah.
go back. They did? So this rounded to the nearest cent. So the cent place is there, right? And so this is the nearest cent. And so this is 30.5277 cents. Isn't that right? 0.30 is 30 cents. So it's a 2 decimal shift to get over to this. And if they wanted rounded it to the nearest cent, the 5 would come in play, because 5 is high enough for the 30 cents to go to 31. Now let's do this one. This is 0.28. When you do cents, this would be 28 cents, but there's more to it. 28.866, whatever, in cents. Clearly, this should record as 28 cents, 0.28. And so it's 28 there. The question is, this one, if you have to round it to the nearest cent, the 8 is going to make this go to
9.
9. The trick about rounding is to wait until the last second. If you round too soon, it gets all fouled up. And so what I did, I used a calculator, I'm telling you that right now, and it gave me this number. That was in dollars, because this was originally in dollars. But I saw this, when I looked at it, as 30 cents. So I put my decimal here, and then I copied the rest of the numbers and said cents, but I had far more than I needed. All I needed was this 5, because this 5 made my 30 cents go to 31 cents. Same exact thing I did here. The 8 made my 28 go to 29. So, I mean, it really has to do with, in dollars, this is a different problem. In dollars, that's 0.45, but in cents, it's 45 cents. So it is a 2 decimal shift to go from dollars to cents.
So Professor, we're not going to be able to use calculators though on the exam.
So I'm going to have to make a nice sweet problem.
Okay, well, because the way that I did this was in the beginning, I moved, because you have to move decimals on both. So it was 0.36 and then you move it and then do long division, correct?
Well, there's no point in the 36. The fact that you survived that was just your good fortune.
Well, how else would you do it without a calculator? Because if you
would
move
have to do
one,
it. This is why I didn't bother, because it would take this too long and we're running out of time.
that's what, okay.
That's what you have
Okay.
to do without a calculator. Yeah. So, but anyway, I wanted to show you the result of it. And sometimes I think they should just let you use a calculator. Okay, so what I want to do, we're still talking about, so I'm going to extend 5.5, but what you need to do is Chapter 10, you're going to have to work with that. We didn't do too much with that. Let's see. But I think your best plan, this is chapter 5 and chapter 10 on Monday. Chapter 10 was the positive and negative numbers. Chapter 5 was this work with ratio and proportion. Your best place to work is, where is it? Test reviews at the bottom here. This one. Okay. So this one here, those are your problems you work through. What you need to do, is there anything left from either chapter 5 or chapter 10 that we need to look at right now?
There was one and it was like a double digit. I can't remember, and it
I think I know
had
what
to
Sophia's
figure
trying to
out.
talk about. So, and for proportions, in 5.4, question 7, there was a fraction, so it was x
5.4.
over 16, then equals the fraction of 1 over 8, and then over that was 1 over 6.
Okay, that's a good one. Let me take us back. Wish I could do this quickly. So tell me again, because I remember that kind of problem. X over,
16,
okay?
then equals 1/8 over 1/6.
Yeah, that's it.
Okay, it looks bad, but the truth of the matter is it would use the same, and there was equals here?
Yes.
Mhm. So this is 1/6 times X. And this is 16 times 1/8. I can see where you get in trouble with this. This side is good. This 16 over 1 times 1 over 8 could easily be reduced. 8 goes into 16 twice and into 1. And so when you multiply across, this correct side is just 2. If you went this route, you might not know what to do. 1/6 of the answer is 2. Maybe you could guess it. 1/6 multiplied by what number would give you 2? Can anybody
One.
guess it? And I'll show you how to avoid this. Can anybody see it? Wouldn't that do it? If I multiplied by 12,
Oh,
it would give you, X would be 12. Because we haven't done equations yet, this is guessable because this side simplified, but the answer is 12. But let me show you what would have to be done to do it where we are right now. The part of this problem that's driving us crazy is right here. And if somehow we could make this the simpler version, we would be so much better off. So I'm going to deal with that. This is 1/8 divided by 1/6. That's what that is, 1/8. The fraction line is divided by 1/6. I'm going to do this back the fraction way. This is 1/8 multiplied by, remember what happens?
Over 1.
6/1. I'm going to reduce it. 2 goes into 6, 3, and into 8, 4. The simple answer is 3/4. Don't I like 3/4 instead of this mess? And so now it's not going to get us in trouble. X/16 equals 3/4. I can deal with that. You can deal with that. So literally what we did is we say, I love this expression. I saw a mess and I cleaned it up. Right? Did I like the look of that? No, I didn't. And so now it's solvable. This is x times 4, we would write as 4x. This is 16 times 3, this is 48. We know the step. We need to get rid of the 4, so I divide both sides, and x equals 12. That's how we would do it with our skills at the moment. So what I was trying to say, I'm going to actually stop, but stop recording. But what you need to work through those problems that I showed you, the review problems. And then if you have trouble, send me an email and I'll type up the answer for you. And if you don't like it, we'll go on Zoom this weekend. Simple as that. And people have done this before, and I'm tutoring left and right. And so don't feel like it's a imposition, because that's what I'm supposed to help you do, is go over things. And so if you would line up your problems, 3 or 4 or 5, whatever you have, that are driving you crazy, that's wasting your good time, then send me an email and said, are you available Saturday or something? I don't know, whatever. And I'll tell you, and we'll work together. How's that for a plan? I think.
Thanks, Madison. Thank you.
Thanks a lot. That really.
I hope that'll work. Let me
helped it.